In the vast and silent theater of the cosmos, where stars are born and die in an eternal ballet, an unexpected visitor traverses our solar system. Named 3I Atlas, this interstellar object is only the third of its kind ever detected, following in the footsteps of Oumuamua and 2I Borisov. But unlike its predecessors, 3I Atlas carries with it an enigma that challenges our understanding of the universe. On October 24, 2025, something extraordinary happened. For the first time in the history of astronomy, an interstellar object emitted detectable radio signals. The Meerkat radio telescope in South Africa captured hydroxyl absorptions at frequencies of 1,665 and 1,667 gigahertz emanating from 3I Atlas, a phenomenon that had never been observed before in any visitor from beyond our solar system. The detection sent shockwaves through the scientific community. Radio signals from space are not uncommon. Pulsars, quasars, and other cosmic phenomena regularly broadcast across the electromagnetic spectrum. But this was different. This was a wanderer from another star system, carrying the chemical fingerprints of its distant home, now speaking to us in the universal language of radio waves. Dr. Avi Loeb, the renowned astrophysicist from Harvard, described the discovery as providing a fingerprint of water molecules breaking down on the comet. The hydroxyl radicals detected are the telltale signature of water vapor dissociating under solar radiation, a process we've observed countless times in comets native to our solar system. Yet here was an alien visitor, billions of years old, exhibiting the same fundamental behavior, but the implications run deeper than simple comet activity. These specific frequencies, 1,665 and 1,667 gigahertz, are well known to astronomers. They represent the absorption lines of hydroxyl radicals, molecules that form when water breaks apart under the intense radiation of our sun. The fact that 3I Atlas exhibits this behavior suggests that despite its interstellar origins, it shares fundamental characteristics with objects formed in our own cosmic neighborhood. The discovery raises profound questions about the nature of planetary formation across the galaxy. If an object born in the gravitational embrace of a distant star can exhibit the same chemical processes as our local comets, what does this tell us about the universality of cosmic evolution? Are the building blocks of life, water, organic compounds, complex molecules, truly ubiquitous throughout the galaxy? Yet not everyone in the scientific community agrees on the interpretation of these signals. While NASA maintains a cautious stance, emphasizing the need for rigorous analysis before drawing conclusions, other voices in the astronomical community have raised more provocative possibilities. The timing and trajectory of 3I Atlas have reignited one of astronomy's most enduring mysteries. The object's path through space appears to originate from the same region of sky where, in 1977, the famous WOW signal was detected, a powerful radio transmission that lasted 72 seconds and has never been explained. The probability of this being mere coincidence, some researchers suggest, is approximately 0.6%. This statistical anomaly has sparked intense debate. Could there be a connection between the 48-year-old mystery signal and this interstellar visitor? Is 3I Atlas merely a natural wanderer, or could it be something more deliberate? A messenger carrying information across the vast distances between stars? The scientific establishment remains divided. NASA's official position emphasizes caution, urging the community to avoid premature speculation without substantial evidence. Their researchers point to the hydroxyl emissions as clear evidence of natural cometary activity, nothing more exotic than water vapor interacting with solar radiation. But theoretical physicist Michio Kaku and other prominent scientists have expressed fascination with the broader implications. The detection of radio signals from an interstellar object, regardless of their origin, represents a watershed moment in our understanding of how information travels through the cosmos. As 3I Atlas continues its journey through our solar system, observatories worldwide are mobilizing resources to study this enigmatic visitor. The European Southern Observatory, the Atacama Large Millimeter Array, and dozens of other facilities are training their instruments on the object, seeking to decode the secrets it carries from the depths of interstellar space. The hydroxyl signals detected by MeerKAT represent more than just molecular emissions. They are the first words in a conversation between humanity and a visitor from the stars. Whether these words tell a story of natural cosmic processes or something far more extraordinary remains to be seen. What we know for certain is that 3I Atlas has already rewritten the textbooks. Never before have we detected radio emissions from an interstellar object. Never before have we had the opportunity to study, in real time, the chemical composition and behavior of matter that formed in another star system billions of years ago. The object's closest approach to the Sun occurred in January 2025, but its radio emissions continue to provide a treasure trove of data. Each signal captured by our radio telescopes adds another piece to the cosmic puzzle, bringing us closer to understanding not just this particular visitor, but the nature of interstellar space itself. But what scientists found next would challenge everything they thought they knew about the boundaries between natural phenomena and the possibility of intelligence among the stars. The detection of hydroxyl absorption lines from 3I Atlas by the MeerKAT radio telescope on October 24, 2025, marked a pivotal moment in our understanding of interstellar objects. This unprecedented observation prompted a flurry of scientific activity, as researchers worldwide sought to unravel the mysteries surrounding this celestial visitor. Initial attempts to detect radio signals from 3I Atlas in September 2025 were unsuccessful. The object's proximity to the Sun posed significant observational challenges, with its angular separation being a mere 376 degrees, approximately 7 times the Sun's diameter in the sky. Despite these hurdles, the successful detection in October provided a unique opportunity to study the object's composition and behavior in unprecedented detail. The radio signals revealed far more than simple water vapor emissions. Spectroscopic analyses conducted by multiple observatories showed that 3I Atlas exhibited an extreme enrichment of carbon dioxide with a CO2 to water ratio of 6+0.3. This ratio is significantly higher than that observed in typical solar system comets, suggesting that 3I Atlas has undergone extensive galactic cosmic ray processing during its interstellar journey. Such processing likely transformed its outer layers over millions of years of travel through the harsh environment of interstellar space. The bombardment of high-energy particles would have gradually altered the chemical composition of the object's surface, creating the unusual molecular signatures now being detected by Earth's radio telescopes. Further observations revealed the presence of hydrogen cyanide emissions with a production rate of approximately 4.0x10^25 molecules per second. This finding indicates active outgassing processes, providing crucial insights into the volatile inventory of 3I Atlas and offering clues about the conditions that existed in its home star system billions of years ago. High-resolution imaging from the Keck Cosmic Web Imager revealed spatial profiles of cyanide and nickel emissions emanating from the object. The nickel emission was found to be more centrally concentrated within the nucleus, suggesting the presence of easily dissociated species such as metal carbonyls or metal polycyclic aromatic hydrocarbon molecules. This observation offers unprecedented clues about the thermal and chemical history of an object born in another star system. As 3I Atlas approached perihelion on October 29, 2025, it exhibited a rapid increase in brightness that caught astronomers by surprise. Space-based instruments, including NOAA's GOES-19 satellite and NASA's Punch mission, tracked this brightening phenomenon in real time. The sudden luminosity increase was consistent with dramatically increased gas emissions as the comet heated up near the Sun. But the intensity exceeded models based on typical cometary behavior. This brightening event provided a rare opportunity to study how interstellar material responds to solar heating. The data collected during this period revealed that 3I Atlas was releasing gases at rates far exceeding those predicted for an object of its size and composition, suggesting that its internal structure might be fundamentally different from solar system comets. The unique characteristics of 3I Atlas have sparked intense debates within the scientific community. Theoretical physicist Michio Kaku has highlighted anomalies such as unexplained accelerations and what he describes as periodic magnetic pulses detected during radio observations. These features, Kaku suggests, could challenge existing astrophysical models and warrant investigation beyond conventional cometary science. However, the scientific discourse around 3I Atlas has been complicated by misinformation. Several viral videos claiming to feature Dr. Kaku making extraordinary statements about the object have been identified as deepfake productions, misrepresenting his views and contributing to public confusion about the true nature of the discovery. NASA has responded to the unusual behavior of 3I Atlas by activating enhanced monitoring protocols through its Planetary Defense Coordination Office. While emphasizing that the comet poses no threat to Earth, the agency has acknowledged that the object's unexpected characteristics warrant close scrutiny and coordinated international observation efforts. The investigation has revealed that 3I Atlas carries within its ancient ice and rock a record of conditions that existed in its birth system billions of years ago. Every molecule released as it approaches the Sun tells a story of stellar formation, planetary disk evolution, and the chemical processes that shaped matter in a distant corner of the galaxy. Radio telescopes across the globe continue to monitor 3I Atlas as it begins its journey back toward interstellar space. Each day brings new data about its composition, structure, and behavior, information that is rewriting our understanding of how matter behaves during the vast journey between star systems. But the most intriguing discoveries were yet to come, as deeper analysis of the radio signals would reveal patterns that defied conventional explanation. As researchers delved deeper into the radio emissions from 3I Atlas, a series of anomalies emerged that challenged conventional understanding of interstellar objects. What began as a straightforward detection of hydroxyl absorption lines evolved into a scientific puzzle that divided the astronomical community. The first anomaly surfaced in late September 2025, when data from the Goldstone radar facility revealed an unexpected acceleration in 3I Atlas's trajectory. Over a 48-hour observation period on September 25th, the object exhibited a 0.02% increase in velocity that could not be explained by standard outgassing models. This non-gravitational acceleration, while small, was significant enough to catch the attention of researchers worldwide. Theoretical physicist Michio Kaku was among the first to highlight this deviation, describing the acceleration pattern as too deliberate to ignore. The phenomenon drew immediate comparisons to Oumuamua, the first confirmed interstellar visitor, which also exhibited unexplained acceleration during its 2017 passage through our solar system. However, unlike Oumuamua, 3I Atlas was actively outgassing, making the acceleration even more perplexing. The mystery deepened on October 4, 2025, when multiple radio observatories reported detecting periodic magnetic pulses emanating from 3I Atlas. These pulses occurred with remarkable regularity every 147 seconds, a periodicity that defied existing astrophysical models for cometary behavior. Kaku noted that such perfect periodicity was unprecedented in the study of interstellar objects and lacked explanation within current theoretical frameworks. The magnetic pulse phenomenon sparked intense debate within the scientific community. While some researchers proposed that the pulses could result from the interaction between 3I Atlas's magnetic field and the solar wind, others argued that the precision of the timing suggested a more complex underlying mechanism. The pulses appeared to correlate with the object's rotation period, but the relationship was not straightforward. Perhaps the most startling revelation came from trajectory analysis conducted by astrophysicist Avi Loeb and his team at Harvard. Their calculations revealed that 3I Atlas's path through space originated from the constellation Sagittarius, the exact same region where the famous WOW signal was detected in 1977. This powerful 72-second radio transmission had remained unexplained for nearly 5 decades, representing one of astronomy's most enduring mysteries. Loeb's statistical analysis determined that the probability of this alignment being purely coincidental was approximately 0.6%. The implications of this connection sent ripples through the scientific community, raising questions about whether there might be a deeper relationship between the mysterious signal from 1977 and the current interstellar visitor. The coincidence reignited discussions about the nature of the WOW signal itself. Detected by the Big Ear radio telescope at Ohio State University, the signal exhibited characteristics that suggested an artificial origin. It was narrowband, occurred at the hydrogen line frequency of 1420 MHz, and showed the expected Doppler shift pattern of a source in space. However, despite numerous attempts, the signal was never detected again. As news of these anomalies spread, the scientific discourse became complicated by the emergence of misinformation. Deepfake videos began circulating on social media, falsely portraying scientists like Michio Kaku, making sensational claims about 3I Atlas's extraterrestrial origins. Kaku himself was forced to publicly address these fabrications, emphasizing the importance of relying on verified scientific data rather than speculative interpretations. NASA maintained its cautious stance throughout these revelations, emphasizing the need for rigorous analysis before drawing conclusions. While acknowledging the unusual characteristics of 3I Atlas, the agency refrained from speculation about the object's origins, focusing instead on comprehensive data collection through enhanced monitoring protocols. The agency's Planetary Defense Coordination Office activated international collaboration efforts, bringing together observatories from around the world to track and study the object. This coordinated approach aimed to gather as much data as possible before 3I Atlas moved too far from the Sun to permit detailed observation. Yet with each new discovery, the mystery of 3I Atlas only seemed to deepen, challenging our fundamental assumptions about the nature of interstellar space and the objects that traverse it. The arrival of 3I Atlas has fundamentally altered our perspective on interstellar objects and their role in the cosmic narrative. As this ancient wanderer continues its journey back into the depths of space, it leaves behind a legacy of scientific discovery that will influence astronomical research for generations to come. The detection of hydroxyl absorption lines at 1,665 and 1,667 GHz represents more than just a technical achievement. It marks humanity's first direct chemical conversation with material from another star system. The water molecules breaking apart under our sun's radiation carry within them the story of their formation billions of years ago in the gravitational embrace of a distant star we may never identify. Analysis of the radio emissions has revealed that 3I Atlas underwent extensive galactic cosmic ray processing during its interstellar journey. The extreme enrichment of carbon dioxide with a CO2 to water ratio of 7.6 plus 0.3 tells the story of millions of years spent traversing the harsh environment between stars. High-energy particles bombarded its surface, gradually transforming its chemical composition and creating the unique molecular signatures we observe today. The scientific community's response to 3I Atlas has highlighted both the power and the challenges of modern astronomical research. While the Meerkat radio telescope's detection provided unprecedented insights into interstellar chemistry, the subsequent discourse revealed the vulnerability of scientific communication to misinformation. Deepfake videos falsely attributed sensational claims to respected scientists like Michio Kaku, demonstrating how quickly false narratives can spread in our interconnected world. Kaku himself has emphasized the importance of maintaining scientific rigor while remaining open to unexpected discoveries. His observations about the object's anomalous acceleration patterns and periodic behaviors have sparked legitimate scientific debate. But he has consistently advocated for evidence-based analysis rather than speculative interpretation. NASA's measured response to the 3I Atlas phenomenon exemplifies the careful balance required in modern astronomy. The agency's activation of enhanced monitoring protocols through its Planetary Defense Coordination Office demonstrated the seriousness with which they approached the object's unusual characteristics, while their emphasis on rigorous analysis helped maintain scientific credibility amid public speculation. The international collaboration that emerged around 3I Atlas observations represents perhaps the most significant outcome of this discovery. Observatories from around the world coordinated their efforts to study the object, sharing data and resources in an unprecedented display of scientific cooperation. This collaborative approach maximized the scientific return from the brief window of opportunity provided by the object's passage through our solar system. The study of 3I Atlas has also revealed the remarkable universality of certain cosmic processes. Despite originating in another star system, the object exhibits the same fundamental behaviors we observe in local comets: water vapor dissociation, outgassing patterns, and chemical evolution under solar heating. This similarity suggests that the physical and chemical laws governing planetary formation are truly universal, operating consistently across the galaxy. Perhaps most profoundly, 3I Atlas has reminded us of our cosmic connectivity. The atoms and molecules within this interstellar visitor were forged in the nuclear furnaces of distant stars, traveled for millions of years through the void between worlds, and briefly shared our solar system's warmth before continuing their eternal journey. In studying 3I Atlas, we are literally examining the building blocks of worlds we will never see. The object's detection has also underscored the importance of continued investment in radio astronomy and space-based observation platforms. The hydroxyl emissions that made this discovery possible were detected using cutting-edge technology that represents decades of scientific and engineering advancement. Future interstellar visitors may carry even more profound secrets, but only if we maintain and expand our observational capabilities. As 3I Atlas fades into the cosmic distance, it carries with it our hopes and questions about the nature of interstellar space and the possibility of other worlds. Its brief visit has expanded our understanding of the universe while simultaneously revealing how much we still have to learn about the vast cosmos that surrounds us. The radio signals from 3I Atlas may have fallen silent, but their message continues to resonate through the halls of observatories and universities worldwide, inspiring a new generation of scientists to listen more carefully to the whispers from the stars.